Now, the next topic is Einstein's particle nature of light, the photon. Well, it has 5 points, okay, that I have to discuss. That's it. So then we are done with this topic. So that is particle nature of light. Particle nature of light. Particle nature of light. Here it is, the photon. Okay, the photon. Particle nature of light, the photon. Okay. Now, so he says that light travels in the form of quanta or packet of energy. Okay. He says that Albert Einstein, he told that light travels in the form of quanta, that is energy packets. Quanta, light travels in the form of quanta or energy packets. Energy packets. So what are the conclusions here? Number one, he says about the first point. That is, when there is an interaction between matter and radiation, radiation with matter, then what happens? It is made up of particles called photons. But radiation behaves as it is in the made up of photons, particles called photons. So, in interaction of radiation with matter, light behaves. Okay, radiation behaves like photons. Okay, radiation behaves like particle nature, or photons behaves like photons. Okay, this is the first one. Second one, the second one, he says each photon has an energy and momentum. Each photon has an energy, has momentum. Each photon has a momentum. P is equal to what? mv. P is equal to, be right here. That is P is equal to h nu by c, and E is equal to h nu by c, and energy is equal to what? Energy is E is equal to h nu. From where we got this equation? We have C is equal to nu lambda. So C is equal to nu lambda, and is h by p, right? So lambda is equal to c by nu. Okay, lambda is equal to c by nu. So we have the formula. Lambda is equal to h by p. From lambda is equal to h by p, we got from where? From de Broglie wavelength. Okay, this is de Broglie wavelength. So just substitute that, we will get this formula. This is the second point. The third point, he says that, so the same thing. He says it is independent of photon. Every photon, suppose if you are selecting one particular frequency of incident radiation, the energy of each and every photon will remain same for one particular frequency. Okay, I'll just write that. So here, fourth, I'll erase this one. So here it says that third one, for one frequency of light, okay, energy of each photon remains same. That won't change. Energy of each photon remains same. Okay, same energy. Means photon energy is independent of intensity of radiation. Okay, photon energy is independent of intensity of radiation. Photon energy is independent of radiation intensity. radiation intensity. Fourth one. Is it clear? So these points they can ask you in assertion reasoning also. And photons are electrically they are neutral. Okay. So photons are neutral. They are not deflected by. They are not by electric or magnetic field. Electric or magnetic field. Okay. Here, fifth one. The fifth point is when there is a photon electron collision. Okay. When there is a photon and particle collision, energy and momentum are conserved. In photon electron collision, energy, momentum and energy are conserved. Momentum and energy are conserved. Okay. Momentum and energy are conserved. Is that clear? So once again, see from the beginning, particle nature of the photon. So he says that light travels in the form of quantum or energy packets. So in interaction of radiation with matter, radiation behaves like photons. It's particle nature. Each photon has momentum P is equal to h nu by c, or energy E is equal to h nu. So we are using the formula lambda is equal to h by p, that is from de Broglie wavelength, and c is equal to nu lambda. What is c here? What is c?
Speed of light.
Speed of light. Very good. So what is the value of speed of light?
3 into 10 raised to 8 meters per second.
Very good. 3 into 10 to the power of 8 meter per second. For one frequency, energy of each photon remains same. That is, photon energy is independent of intensity, radiation intensity, and photons are neutral. They are not deflected either by electric or magnetic. In photon electron collision, momentum and energy are conserved. Is that clear? Is this clear all of you?
Yes, sir.
Okay. Yes, sir.
So we are done with this lesson. Okay, we will start now at atomic structure. It's a small lesson, atomic structure, not even this much also. It's atomic atoms and nuclear, very small lessons. So both postulates are there, that only we have to discuss, and then there is a derivation for radius and energy and velocity of electron. Just check if anything is deleted in that one. Can you copy that and paste it in that one? The atoms topic. What is deleted? I will come to know. So are you done with this?
Yes, sir. Just checking the portion, sir.
Okay, right.
Sir, you want atoms and nuclei portions, no?
What is it?
You want atoms and nuclei portions, right?
Atom, yeah, atom and nucleus. That's it.
Okay, one minute.
I'll send you the notes also. Today, the remaining topics notes also I'll send you by evening, most probably.
Yes, sir. Sir, I sent the portions in this meeting chat.
Yeah. So what is there in our syllabus? We have this is nuclear physics, right? Atoms, okay, atoms, alpha particle scattering experiment, Rutherford model of atom. So Rutherford model of atom, and then Bohr's model. Bohr's model of hydrogen atom. Then okay, velocity he's asking, and energy of electron and the hydrogen. Qualitative treatment means he's not asking the derivation now. Qualitative. No, there are three derivations. He's asking only the, he's not asking the derivations. Sorry. The only explanation is asking. Okay, we can finish it off. Okay, we will not take much time for atoms and atoms chapter. Okay, only the experiment I have to explain. Okay, shall we start next one now? Yes.
Yes, sir.
Yes,
Okay,
sir.
we'll go ahead now. Okay. So there were three derivations. They have removed those three derivations also because they said that qualitative explanation they want. Now, so atoms chapter, or we also say atomic structure or atomic physics or atomic structure. This is in chemistry first lesson, I think, first or second lesson. Atomic structure. I think you studied in chemistry. Is it not? Do you remember this one? Okay. Anyways, we will start with the first one. Like atoms are the, as I told you yesterday's class. Atom is the smallest indivisible particle in the nature, and we have fundamental particles. What are they? What are the fundamental particles? Electrons, protons, and neutrons. Is it not? These are the basic building block of an atom. Electron, proton, neutron are the basic building block of an atom. Now, We start with the first. Okay, I'm not going to explain again. Yesterday I already wrote what is the charge of electron, mass of electron, and what is the charge of proton, mass of proton, and neutron also. Charge and mass of neutron, that already we discussed. I'm not going to waste time. Directly I'm going to the first model, that is J.J. Thomson atomic model. Okay, so the first one is J.J. Thomson's
Plum pudding.
plum pudding model. Okay, that is watermelon model, atomic model. So there are two names for this. One is plum pudding model or watermelon model. Plum pudding model, or it is also known as watermelon model. So these are the two names. Okay, what have been given. Now, so we have according to this, atom is like a watermelon. Atom is like a watermelon. Watermelon. Okay, so he says that, like, suppose this is a watermelon, and now there are seeds in the watermelon. Okay, so these are negative charge. He didn't disclose that they are electrons, but at that time electrons were not discovered. Okay, so he discovered of electron. So this is the positive flesh. This is positive charge, and these seeds are negative charge. The seeds are negative charge, and the flesh is known as the positive charge. Is that clear? Atom is like a watermelon. So the seeds are acting like negative charge, and the flesh is acting like a positive charge. So what is the drawback of this? The drawback is drawback of this is what he could not explain the stability of an atom. Okay, stability and conservation of charge. What is conservation?
Charge is neither created nor destroyed.
Yeah, charge is neither created nor destroyed, but can be converted from one form to can be transferred from one body to another body. So he could not explain these two concepts. So that is why his theory was discarded. Then after that, later on came Lord Rutherford. Okay, why he has given a lot of importance? Because he himself got the Nobel Prize, and his 3 students also got the Nobel Prize. Okay, Bohr is one of the student of Rutherford, Neil Bohr. Okay, he's a student of Rutherford. So now the Rutherford model we will see now. Okay, any doubt in this one? The first one, J.J. Thomson's atomic model.
No, sir.
Okay, so we'll go with the next one, that is Rutherford's atomic model. Rutherford's atomic model. So according to this model, okay, he says that, see, it's like this. Now this is proton and neutron. Electrons are revolving around the nucleus. Okay, so he says that the first one, atom is spherical in shape. Atom is spherical in shape. Okay, the second one is what? The entire mass of the atom. The entire mass of the atom is concentrated. The entire mass of the atom is concentrated
in the nucleus.
At the center of the atom, called nucleus. At the center of the atom, called nucleus. Okay, is it clear? The third point is nucleus is positive in charge. Nucleus is positive in charge. Nucleus is positive in charge. Fourth one is nucleus consists of
positive and
protons and neutrons. Protons and neutrons. And electrons are revolving around the nucleus. And electrons are revolving around the nucleus. Revolving around the nucleus. Like planets revolve around the sun. Like planets revolve around the sun. Like planets revolve around the sun. Is that clear? So nucleus consists of protons and neutrons, and electrons are revolving around the nucleus like planets revolve around the sun. So therefore, this model is also known as, so this model is known as planetary model. This model is known as planetary model. Okay, planetary model. Is it clear? So this model is known as planetary model. Please note down this. Then we'll go to the next one. Any doubt in this? Drawbacks, we'll discuss the drawbacks now. Then we can directly go to the Bohr's atomic model. Okay. Is this clear? All of you?
Yes, sir.
Okay.
Yes, sir.
Just give me 1 minute.
Oh yeah, this guy did the gold foil experiment, no?
Are you done with this?
1 second, sir.
Okay, so shall I go to the drawbacks now? Yes.
Yes, sir.
Can I erase this one?
Yes, sir.
Okay, so here I'm going to the drawbacks of the Rutherford model. Okay. So drawbacks or failures. Drawbacks or failures of Rutherford model. The first one, he says that he said that electrons revolve in spiral orbits like this. And finally, electrons revolve in spiral orbits, and finally they fall into the nucleus, and nucleus will collapse. Okay. So this was told by Rutherford. He says that okay, electrons revolve in spiral orbits. Electrons revolve in spiral orbits, and they lose their energy they lose their energy continuously, and finally falls into the nucleus, and nucleus will collapse, but it is found in the nature. Okay, but it is found in the nature, that the nucleus is, that atom is stable. Okay, there's no collapse, nothing is happening like that. So we found that once again electrons revolve in spiral orbits and they lose their energy continuously, and finally they fall into the nucleus and nucleus will collapse. But it is found in the nature that the atom is stable in nature. And one more thing, second is hydrogen spectrum gives continuous spectrum. Hydrogen spectrum is a continuous spectrum. Second one, hydrogen spectrum gives continuous spectrum. But experimentally it is found that it is line spectrum. But experimentally it was found. Experimentally it was found that hydrogen spectrum is a line spectrum. Hydrogen spectrum is a line spectrum. See here, hydrogen spectrum gives continuous spectrum, but experimentally he said that it is continuous spectrum, but it is not a continuous spectrum. Like, what is spectrum actually in chemistry? We have studied this, right, in chemistry grade level.
Spectrum is basically the light emitted by an excited atom of a element.
No, suppose if I'm a layman is there.
It's the band of light.
Huh?
The band of light.
What
or
is it?
band of certain.
What,
So band, sir, a band of light.
Band of light. I don't know. Suppose you want to make a person explain who doesn't know any knowledge of this band and all. Okay, how will you explain? In simple words, a spectrum is a characteristic of an atom. Every person has a character, right? Like he's a good character or bad character or characterless, whatever it is. It's like he's having some character the same way. So so at this spectrum will give the characteristic of an atom. Now, suppose we have, again in the classification is there, line spectrum, like you have continuous spectrum, discontinuous spectrum, line spectrum, band spectrum, emission spectrum, absorption spectrum, classification is given to you. So when you give the light, simple example I'm giving, like suppose you gave 99 dirhams to a friend and you told him, just give it to that so and so person. So that person, what you did is you took that 99 dirham, you kept the change with you because you needed a change. You just gave the 100 dirham note to that person. You got it. This is one character of a person. And this again, second time, the same friend give you 101 dirhams, 101 dirham, and he told you to pass on this money. So at that time, you kept that 1 dirham and you have only 100 dirhams to him. You understood? One is absorption spectrum, one is emission spectrum. So you are taking some light and giving in first case. Okay, in the second case, you are adding the light to the light. Got it? So we have emission, absorption. So like that, we have classification of spectrum. Is that clear? So this is a very big study that comes under physics of atoms and molecules, okay, where we study about the different spectrum. Ends with the Raman spectrum. Sir C.B. Raman. Okay, you know about him. C.B. Raman in 1927, he got the Nobel Prize in Physics for his discovery of spectrum, Raman spectrum. So in Raman spectrum, we have elastic spectrum, inelastic spectrum, and all. That is in detail. Okay, that I don't want to go, but that is how it goes. Wien's displacement law and all. Many are there. So did you copy this one? Yeah.
Yes, sir.
So can I go with the next one then? Yes, sir.
So,
I'll go with the post postulates. So only that is remaining. Okay, post postulates only remaining. You don't have derivation. No need to worry about it. Okay. So and we have Rutherford alpha scattering experiment is that I need to discuss. That's it. So clear. So can I raise this?
Yes, sir.
Yes, Aaron and Rahul, Suhas, Vishnu.
Yes, sir.
yes,
Yes,
sir.
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 Yeah, done. So can I raise this now?
Yes, sir.
Okay. No noise, sir. What happened? Did not have your breakfast or what?
Yes, I did not have my breakfast, sir.
Okay. Now, next one is Bohr's model, Bohr's atomic model. So before going to that, I would like to discuss alpha scattering experiment. So we'll finish off the Rutherford thing. Then we can directly go to Bohr's. So alpha scattering, alpha particle scattering. Alpha particle scattering. And Rutherford's nuclear model of atom. And Rutherford's nuclear model of atom. Alpha particle scattering and Rutherford's nuclear model of atom. So the alpha scattering experiment, we take this is a lead box or lead chamber. In that we took polonium, source of alpha particle. I'll explain this alpha particle, alpha, beta, and gamma rays separately. Okay. Now what happens here? So this is the photographic plate. So this is a photographic plate. Okay. Photographic plate. So this is a gold file. We have taken a gold file here. A gold file is taken like this. This is gold file. We say alpha scattering experiment or Rutherford gold file experiment also. It's the same. Rutherford gold file experiment. Now, so what happened when the alpha particle was made to incident on a gold file? All the rays got scattered. Okay, they got scattered in different direction. They got scattered in different direction. This is screen or you can say photographic plate or screen. So this is the thing. Now, so if you see carefully here, this is the first diagram. The second diagram is they have taken the lead bricks. See, they have taken lead bricks like this. These are the lead bricks, and then this is source of alpha particle. Okay, now here this is source of alpha particle, and this is this is the thing, and here we have a dotted line. So here this is a